So when we are dividing by radicals, and I know that phrase that I mentioned, rationalizing the denominator, right now that doesn't mean much to you, and I'll explain what that is in a second. But really what we're talking about is if we're dividing by a radical. All right, now there are some easy types of problems, and I'm going to go through some easy ones. If you want to copy these down somewhere in the margins of your page, this is a lot of what you're going to be seeing next week. So you can have a problem where it's just, let's try this one, 10 square root of 2 divided by square root of 2. So using your intuition, what can we do here? Cancel out those square roots of 2, and you're left with 10. All right, that's easy. I hope everyone finds that easy. That's one type of division problem that you might have. And then you might also have a problem like this. Sit down real quick. You might have a problem where it's square root of 6 divided by square root of 2. And using your intuition, what do you think this is going to be? Square root of 3. That's right. So, and just to clarify what's happening, remember you can take your radicals and you can combine things under the radical. You can separate them into their own radicals. And in this case, we can combine these into the same. So it's the square root of 6 divided by 2, which, yeah, in the end is square root of 3. So, again, with that, not too bad overall. Let's look at another problem. We could have 10 square root of 3 divided by 5. So again, just use intuition. What do you think that is? 2 times square root of 3. So this is where we're thinking about like terms. So if I've got 10 square root of 3 divided by 5, then the 10 and the 5 can still divide, right? And that square root of 3, it's there still, it's hanging out, but it's not a like term, so we don't do anything to it. And one last problem. So if I've got 7 square root of 15 divided by the square root of 5, what can we do with this? Yeah, so now the like terms are my radicals. So that 15 and the 5, I could divide those, and that would give me 7 square root of 3. All right, so are these 4 examples, are they making sense? All right, so what we're going to talk about now is another situation. And that situation is something like this. If I have 10 divided by square root of 2, that is not something that we don't have anything, no like terms there. I can't do anything with it. And the thing is, I can't just leave it like that. Because in math, we don't like to have square roots in the denominator. They are what are called irrational numbers. It's hard for us to really understand. If I told you 10 divided by square root of 2, could you tell me approximately what that number is? And even people who are good with mental math, they're going to have to stop and think about that. It's just not something our brains are really good at processing. So it's a lot easier for us if we have a rational number down there. And a rational number is a number that can be written as a ratio. We don't have to get into the nitty-gritty of the difference between rational and irrational, except to say that for our purposes, a rational number is going to be a whole number. That's not the only example, but that's what we're going to end up with. We're going to end up with a whole number in our denominator, and we don't like having that square root of 2 down there. So there is a way we can get around this. And this whole process right now, we are not changing the essential value. What we're doing is we are changing how we show it. So if our answer is 10 divided by square root of 2, that's our answer. And we're just going to write it differently. So let's look at how we could do this. All right. So, and I'll just kind of go through this, explain the process, and then we'll go through some as a class on that worksheet that you have downloaded. So I'm allowed to multiply any number by 1, and it doesn't change its value. So if I did 10 square root of 2 times 1, well, that's just 10 divided by square root of 2. All right. So I can do that, but I'm going to multiply by 1 in a special way. I'm going to multiply by this radical that I have, square root of 2. Is this the same as 1 right here? Yeah. So I'm just multiplying this original number by 1. I'm just writing the 1 in a special way. I took my radical in the denominator, and I'm multiplying that number over itself. Okay. So now that I have it set up that way, I can multiply across. 10 times square root of 2 is just 10 square root of 2. Square root of 2 times square root of 2 is square root of 4. And what is the square root of 4? 2, a whole number 2. So now, 10 square root of 2 divided by 2, and I can do, now you can see we have something we can work with. 10 divided by 2 is 5, so that gives me 5 square root of 2. And that is the simplified form of it after I've rationalized the denominator. All right, so not too bad. And honestly, this is primarily the kind of math problems you're going to be working on next week. We're going to see some way more complicated things today. But as long as this basic idea is making sense as you go through the problems today, then you're going to be in good shape. All right, so let's actually go back to the worksheet now. Well, just one last thing. If you wanted to double check this, you could take your calculator and do 5 times square root of 2. You could do 10 divided by square root of 2. Make sure it's the same number, and it should be. And maybe you can see the difference. For me, 5 times square root of 2 is a little easier for me to guess what that would be compared to 10 divided by square root of 2. So I think most people would agree that's a prettier answer. It's easier to comprehend. All right, so let's go back to these. And now we're looking at the worksheet that you have. Lots of examples, and like I said it before, but problems 1 through 10, maybe, these are the ones that you're going to be seeing stuff more similar to. When it starts getting to 11 and higher, I want you to practice with those because this is a good skill to have for math that you'll see in the future. But we're not going to be seeing anything that crazy with the stuff next week. All right. So we'll just go to any one of these up at the top. Let's look at number 3. So number 3 looks innocent enough. 5 divided by square root of 5. But we want to rationalize that denominator. So what do you think we're going to multiply by?
Square root of 5 over square root of 5.
There it is. Square root of 5 over square root of 5. I took whatever my radical in the denominator, whatever that is, multiply by that number over itself. Remember, that just is multiplying by 1. I have to keep re-emphasizing that. But now we can multiply across. 5 times square root of 5 going across in the numerator is going to be what? 5 times square root of 5, yeah. Not really much we can do with that right now. What is square root of 5 times square root of 5? Square root of 25. And we know the square root of 25 is 5. So now I still have the same numerator, but now this can be simplified in the denominator to the whole number 5. I mentioned this yesterday, but I want to reemphasize the single most common mistake that's made is having something like this. Square root of 25, and you take the square root of it, and you write the square root of 5 right here. Okay, and that's not what that is, okay? So that was incorrect right there. It's just the whole number 5 when you take the square root of a perfect square. All right, but now we can still cancel out. We can get a final answer because, anyways, I hope it's obvious that 5 and 5 will cancel out. So the answer here is just square root of 5. Okay. So how was that? Easy? Good. Do you need to see any more 1 through 10? All right. I do want to go through one of these that's like down later on in the worksheet because these can get to be a lot more steps involved. So if we look at number 6 real quick, because you just threw that one out there. That negative, I just want to show you, we could probably just do the first step and realize that that negative doesn't change much. That negative just hangs out at the front the entire time. What are we going to multiply number 6 by? Square root of 3 over square root of 3. And then, we're going to have a negative out in the front of the next step, but we still just multiply across. And you can double check that one. Yeah. Anyways, if you need to see the final answer to that one, we can look at that more. But I wanted to focus on maybe some of these more difficult ones. And we can go through a couple of these because they're not easy. So if we look down at the bottom of the page, which one do you guys want to do? 16? All right. So there are some things we can do. I mean, there's a lot of ways of approaching these types of problems. So there's not just one correct method for solving it, but maybe for our purposes it would be easiest if we just kind of go through a very consistent way. So number 16, that's what we're looking at. What are we going to multiply by? All right. Yeah, and it's good we're looking. So with this, you actually only need to multiply by the radical. That 5, even though it's down there, we don't need to worry about it. So what would we multiply by? There it is. And I'll try and write this bigger. So square root of 12 over square root of 12. And we can multiply across. So you'll need your calculators for this, probably. And what do we get when we multiply across in the numerator? Okay, so give me the full numerator. Okay, well, it should just be 2. Yeah, we have just a whole number 2 and the square root of 96. So remember, we're multiplying like terms. Our radicals are the like terms here. So that 2 is just kind of hanging out. Sometimes the 2 is just hanging out. Sometimes the radical is just hanging out. But if there's not a like term, we just kind of leave it kind of hanging out. 5 square root of 12 times square root of 12 is going to give me 5 times square root of 144. All right. And now we can keep going. 2 square root of 96, that doesn't change. But what is the square root of 144? 12. So now we have 5. I'm going to write 5 times 12. I'm not just going to multiply it out. Because, we can do that and then simplify from there. We could also kind of look at this and realize we got this 2 and this 12. Can we do anything there? This is where you're going to have to think about what you can do with fractions. All right. If no one remembers what we can do here, then let's just multiply it out. All this does is save us one little step, but it's not that big of a deal. So let's just multiply across. We get 2 times the square root of 96, and then 5 times 12 is? 60. So now what we can see is 2 and 60 have a common factor. What is it? 2. Yeah, so we can divide this 2 by 2, and you get 1. 60 divided by 2 is what? 30. So this is not our final answer, but now we're looking at square root of 96 over 30. All right, now you can see how these bigger ones can get a little more complicated. So square root of 96, can that be simplified? This is going back to what we were doing yesterday. is there a perfect square that factors into 96? There is. The perfect squares are those white numbers on the diagonal there. Yeah.
Oh, 96. 9.79.
So you can try 96 divided by 4, 96 divided by 9, 96 divided by 16. Six times what? 6 times 16. All right, so this is going back to what we were doing yesterday. So we're not done with that because we're just adding it into this new skill. So now this is the same as 16 times 6 all over 30, which, just as a reminder, that's the same as square root of 16 times the square root of 6 all over 30. All right, what is the square root of 16? 4. And the last thing we can do right here, 4 and 30, is there any common factor? 2. We can divide both of these by 2, which will give me a 2 right there and 15. So my final answer, I'll try and squeeze this in, not making it too small, is 2 square root of 6 all over 15. Neither one of these, the one we started with and the one we ended with, neither one of them is necessarily a very pretty number. But personally, 2 square root of 6 divided by 15 is easier for me to comprehend than this original one. I really have a hard time just quickly thinking, oh, the square root of 12 is going to be about this number. But now we only have one radical to work with, and it's in the numerator. So as far as this goes, for the rest of class, you have about 20 minutes. I want you guys to practice with this. Focus on the ones at the top, but definitely challenge yourself with the ones at the bottom as well. And the last thing I want to mention, I'm not going to go through a whole problem. Number 14 looks really complicated. And I want you to just stare at it for a second. What do you notice about all those numbers in number 14? Is there anything that jumps out? There's whole numbers there, but what else? Perfect square. We can make our lives a little bit easier here if we realize that the square root of 16 is what? 4. So that's just saying 3 times 4 all over 5 times square root of 12. All right, now I won't do anything more on that problem, but there you go. All right, so I'm certainly available to help you guys, but get as many of these done, start at the beginning, get as many done as you can. Make sure you're feeling comfortable with the process.